So, hello everybody, welcome to my talk. I'm Sergio Sastre, I'm an Android engineer, what a surprise, right? And today I'm gonna talk about snapshot testing, what is snapshot testing, how we can benefit from it. I will also give some advice and some examples. So, let's go. So, what is snapshot testing, right? So, snapshot testing is a special type of UI test in which we basically inflate a view, we record a snapshot, and then we compare that snapshot that we have recently taken to another one that we have previously uploaded to the CI, for example, and that is considered to be our source of truth. And snapshot testing has been in the Android world for a while, since 2015, when Facebook released its first open source library. And since then, it has been used more widely than UI tests by very big tech companies. And with very big tech companies, I mean companies like Uber, like 1,000 snapshot tests, just a handful of UI tests. Or Spotify, over 1,500 snapshot tests. And then we have Shopify with over 2,000 snapshot tests and just 20 end-to-end tests. And then we have companies like Airbnb, they go all the way. Yeah? So all in, 30,000 snapshot tests. So why do big companies write more snapshot tests than UI tests? There should be a reason. So let's compare UI tests to snapshot testing, yeah? And let's compare it regarding how hard they are to write and to maintain, and how fast they run. So if you have ever written UI tests, you already know how hard it is, right? So basically, in UI tests, we interact with views. And for that, we use view matchers. And the thing is, we have to find the view matchers that are unique to the ID, the view matchers that we have to find those view matchers that are unique to the view, that we want to interact with. So we start writing UI tests like, OK, view with ID, ABC, click. Then you run the test, and voila, you get something like, hey, ambiguity view matcher exception. And you're like, oh, what's happening here? Yeah, so Espresso actually found another view that has the same ID, and you have to deal with that, yeah? But it's not that easy. Maybe you are using a recycle view, and there are more views with the same ID, or whatever. And that's only for one view, but in UI tests, usually, you interact with several views, yeah? So you also have to consider that the more views you interact with, the longer the test it will take. So even for a very simple UI test, with just 2 or 3 interactions, it might take 5 to 10 seconds, or maybe longer, who knows. But on the other hand, we have this brand new shiny guy, our snapshot test. And this is much simpler. You just sit down and relax. You inflate your view under a given state and record the snapshot. And that's it. And that takes this inflation, and recording the snapshot takes even less than 1 second in most cases. So after all this information, you may be thinking, OK, so why, if it's easier to write a snapshot test and they run faster, why am I still writing UI tests? The thing is, they're not mutually exclusive. They actually complement each other. But why? So on one hand, the user in the UI test focus on the what. They focus on the interaction, on the navigation. They focus on what happens, what is displayed once I scroll a view, I click this other view, I swap this other view. Where do I navigate to? What is displayed? But on the other hand, we have the snapshot test, yeah? And they focus on the how. They focus on how the view is displayed under a given state. And basically, they focus on the visuals. And that's snapshot testing. So what's the motivation to have a snapshot test? So as I've already mentioned, a snapshot tests focus on the visual bags. And visual bags, I mean things like this. So unexpected changes from library updates, because no library is bug-free, right? So sometimes with some updates, we get nice features, but sometimes we also introduce some bugs, yeah? And those bugs might affect the visuals, how it is displayed. Like, for example, material design libraries and also constraint layout I think you all know that. And definitely, snapshot tests can help with that. So the second one is spacing, styling, and themes, and especially themes. Because we want to make sure that every single UI component displays the colors properly in light theme, as well as in dark mode. So the last point is layout correctness. And here, well, there are several subpoints to consider. So one of them is if a view has long text, right? Does it ellipsize or becomes multi-line? Does the text cut? The other one is view overlapping. If we change the visibility of some UI components, do the other elements keep proper spacing among them, or do they overlap, like here? Next point, interesting one, languages. We have to pay special attention to right-to-left languages, just not because we want to make sure that the views align properly, but also sometimes some icons need to be mirrored. Yeah? And there are a lot of considerations with right-to-left languages. And yeah, the last point is the system font size, accessibility thing. When we set it to huge, then it makes all text views to have longer text. And that might create issues like view overlapping, text cutoff, insufficient spacing among elements, and so on. And for this specific case, for system font size, I'm going to display, well, I'm going to show an example. It's a dialog. We want to verify what it looks like with large and largest font sizes. So for that, Android Studio actually comes with a layout validation in which you can test what a layout looks like for different languages, different themes, different screen sizes, and among all those features, also for font sizes. As you can see here, yeah? That's how our dialog layout would look like with large and largest font sizes. At least that's what the layout validation says. If we compare it to the dialog with normal font size, you can see it looks more or less fine. We are missing the bullet points, right? That's because the bullet points are added dynamically in code. And layout validation only knows about what's in the XML layout. And this is not the case. But apart from that, everything looks fine. We are fine to go. But OK, maybe it's a little bit suspicious, yeah. And we want really to know, we want to ensure that the layout validation displays something that is very close to the reality. So for that, we are going to go to settings on our device, display, font size, and then the slider that you see here, just to the rightmost. And we have already set our font size to huge. And then we come back to our dialog layout, and it displays like this. What is actually a little bit different from that. Everything broke. Yeah, like we have I don't know, the delete button doesn't look fine. Also something with the background, the spacing, and so on. And you may be thinking, OK, yeah, I got this point, Sergio, I understand, but how many users do really set the font size system-wide to huge? So in one of the projects I was working on, we were actually tracking the font size of our users when they enter one screen. And the results were like this. So maybe a little bit surprising. I'm not saying that this is happening in every application. But if you put large and huge fonts together, so huge would be largest, it amounts to more than 20% of the users, which is 1 every 5 users, which is a lot, I would say. So let's recap this. Do not trust the layout validation, because it's actually emulating the Android drawing system. So it's not really running on a device. But on the other hand, manual validation is hard. Yeah? So you have to play a lot with the settings. You have to, I don't know, you want to check huge and normal font size, but also light and dark theme. But you also want to check, I don't know, left to right languages and right to left, and so on. And you have to play around a lot with settings, but it's definitely not good. So how can we solve this? Hello, snapshot test. Here we are. So They help definitely to automate these hard things so we don't have to play around with the settings. And at the same time, they catch regression bugs. Yeah, so if you make some unintentional code changes that affect the UI, you get notified. So it's a win-win. So the next point is how snapshot testing works. And this is not that easy. It's not like normal unit test. So it's important to know that for snapshot testing, there are two tasks. Most of the frameworks provide these two tasks. One is record. And record, basically, we record a snapshot of a view that we have inflated. And this usually runs locally. The developers run this locally. And then we have the verify task that is like the record. So we are still recording a snapshot of a view that we have already inflated. But it additionally compares the snapshot to another one that we have previously uploaded to the CI and that is considered to be the source of truth. And this usually runs on the CI, as I've already mentioned. So let's go with the process, how it starts. So you write a test. You see, there's no other way. And then you run the record task. And once you run the record task, you generate a snapshot file. And then we want this snapshot file that is going to be our source of truth to be uploaded into the CI. So we open a pull request, right, with code and also this snapshot file. So this pull request has to be approved. So the snapshot file also has to be approved. We can here include designers, translators, whoever you want, not only programmers. And once it's approved and everything is fine, we just merge, and then this file, this snapshot file, got uploaded into our CI. So now this is considered our source of truth. All the comparisons are going to be made to this. So then it comes another new pull request with some code changes, only code changes, no snapshot file. And these code changes are actually not affecting this layout. So then a verify task runs on the CI with the new code, right? And as I mentioned before, this verify generates a snapshot file. And since there was no change on the layout, as I mentioned, then the verify makes the comparison. And since the comparison is made pixel by pixel, by the way, and since these files look exactly the same, you get a green build. Then another new pull request comes in. And this time we are changing a little bit the layout, but just in the code, and we are still not updating any snapshot file. So it generates a little bit different snapshot, which will be compared, and the build will fail. And there could be two reasons why this build fails. And for that, you have to consider whether that change was intentional or not. If it was intentional, you forgot to record the snapshot, what happens very often at the very beginning. You just have to record the snapshot, then somebody has to approve it, and then you upload it, and it's, again, your new source of truth. And if that change was not intentional, then you got the regression back. Something also very important is the emulator configuration. It really matters. So every single part involved in snapshot testing needs to have the same emulator configuration. And with the same configuration, I mean the same API level, same screen dimensions, and same resolution. Because if it's really like this, then every single part generates the same snapshot file for the same test, obviously. And then when the comparison is made, since all parts generate the same snapshot, everything goes fine. But on the other hand, if we have either one developer with a different configuration, or maybe the CI emulator with a different configuration, then when we are comparing the files, it fails. And why? Because if a device is smaller or bigger or has a different resolution, it will have different number of pixels. And as I mentioned before, this comparison is made pixel by pixel. So it will fail for this reason, maybe for others as well, but for this reason specifically. So let's recap. snapshot testing process. It's more complex than a standard unit testing. As we have seen, there are more steps. And it's also very important that every part involved has the same emulator configuration. Developers and CI, both. So, next point, how to do a snapshot testing effectively. So for that, we are not going to use this example. We'll use a little, one example that comes closer to the reality. So it's a language learning app, better than Babel, maybe, with some customizable training view at the top. There are some text with words we want to memorize in a given language, and once you don't have any other word to train, just on holidays, maybe you can go to Spain, enjoy the beach. So I will give you some advice on how to introduce a snapshot testing to something like this that looks like a real app example. And probably the first approach, or the first that comes to your mind when trying to snapshot test this, is to do full screen snapshot testing. And there are some problems with full screen snapshot testing. So first of all, dealing with asynchronicity. Because it's very common to fetch data asynchronously when we are entering a screen. And at the moment we're entering the screen, there is no data, so what's the point of recording a screenshot? That does not make sense at all. We have to wait for asynchronous operation to finish to display the data, and then we snapshot test it, right? And this means it involves some synchronization mechanism, and that's more work. You can really do it, but that's more work. Second problem is choosing some test-worthy screen states. What do I mean with this? So usually when you are snapshot testing a full screen, there are several views, and each view has its own state. So you are basically testing a combination of view states from the different views. So you have to figure out how to get the screen display a given view state combination. And also, if you are fetching data from the backend, we need to understand the model we get from the backend to show exactly that combination as states. So it requires research. It's something you want to avoid. And the last point is, I'm sorry to tell you this, a snapshot test still might have flakiness, and the problem is the more views you have, the more sources of flakiness you can encounter. What is also bad, and also you analyze the code, and there's more code, so it makes things harder. So basically, these are the three main points why I would not go for full screen snapshot testing. And I will give you some advice. What I will do, first of all, I will start small and simple. So split your screen into smaller testable views. Here is easy because we have a recycle view, and it's composed of view holders. So every view holder is a testable view unit. So it's easy peasy. So when it comes to snapshot testing, we also have to understand what is worth testing, Because honestly, a header, why the hell do you want to test a header? It does not make sense at all. Why? Because it's simple, the user doesn't interact with it, does not bring any value. And in green, we have our training view and text to memorize view. They are more complex, something can really go wrong, the user really interacts with it. So it makes sense. And for this tech talk, I'm gonna go ahead with the training view. So once we have the training view, we want to identify the view states we want to snapshot. So I don't know if you remember the GIF I was showing, but basically there are two states. One in which we have words to train, and another one in which, basically, nothing to learn, so let's go on holidays, empty state. So I'm going to take also the state A because it's a little bit more complex, and I like complex things. So my second piece of advice is to aim to break the layout. What do I mean here? So, for example, I mean things like, everything looks fine, when we have 6 words to train, but what about 1,000 or 999,000 words, would then the figure overlap the words to train text view? Things like, imagine we have 7 languages, also the Latin languages, the Spanish, Italian, Portuguese, and French. it looks like there's not enough space for all the flags to be displayed. So how the layout would be displayed in it, yeah? And then we have other external things, like the system font size that we have already seen, and one more extra factor, like what about narrow screens? So these are all the things, for example, we would like to test. To break the layout, we want to break the layout. So how do we translate this into testable item, something that we can use in our test? Yeah, so let's create some mock data, yeah? So this basically would translate into something similar to this into code. So we have one part that is the training item. This is the data model we are using in production for our view holder. And apart from that, well, like here I'm not going into details, but you see that we are having like 999 more than that 1,000 words per language and so on. So it's really, really extreme. And then we have the external. Yeah, we have the font size and the screen. So then we come to the test itself. Once we already know the mock data we want to use in our test. And the test itself is basically inflating the view under a given state and recording it. This is what I'm going to show now. And for that, I'm going to use one framework that is Shot, but you can use any other frameworks. There are several out there, like Testify from Shopify, Paparazzi, but that's a little bit different from Cash App, and many others. So yeah, this is what it looks like. Let's go piece by piece. Yeah. So the first one is we have to launch an activity scenario and wait for the activity to be ready. This is very important because the context of the activity is going to be used to style the layout under test. So with the styling, I mean like applying material design, so some attributes of material design. So if you are not using you are not inflating the activity and using that context in the layout, then the layout won't be properly styled. So the second point is just, inflating the view. You bind the view to the mock data that we pass as an argument, and then we wait for the UI thread to be idle, because this has to run on the main UI thread. So as you can see, we are, this activity inflate, I created an extension method to basically inflate the view with the context of the activity. And the last part of this code snippet is basically using the method from Shot, in this case, to generate the snapshot file. And here, Shot actually has very cool and handy methods for screenshot testing, view holders, activities, dialogues, fragments, composables as well, of course. So very nice framework. And that's it. That's how it looks all together. So now the next point is we want to inject the mock data into the test. And for that, we're going to use parameterized test. And you will find out why. So this is what it looks like. So again, step by step. The first one, we want to set the runner, the parameterized runner in this case, because I'm going to use JUnit 4, standard JUnit 4, and it comes with this parameterized runner comes with it. And also very important, in the constructor, we are also passing our test item that we saw before. The second step is just generating the test data. Here it's very important to understand that every single item in the array that will be passed to the constructor and is a test. So every single item in this array is going to be a test. So many tests as items in the array. So the last part is just using the method that we have previously saw. So once we have all this, we are ready to execute the record task. And what we get is something like this. Oh, so there is text overlapping, text cutoff, languages do not fit, everything that you can imagine. And it's only for one test. So what if we want to add more tests? More, let's say, not only happy path cases, but also happy path test cases. So as I mentioned before, into this array, we're going to add more methods. Yeah, so we have now 2 for happy path and 2 for unhappy path. And it looks like this. So the happy path is very nice, but the unhappy path, well, there are some visual errors that actually you cannot catch with Espresso, because if you say view is display, the view is display, right? No. So yeah, that's it regarding the second point. My third piece of advice, group test by relevance. What do you mean? So as you have seen, writing a snapshot test is easy. They run fast. So every developer in the team is involved. It's like, yeah, let's get some speed. You get to 100 snapshot tests. You get to 200, 400, easy peasy. At some point, you reach 800. Yeah, and then your build times are like 16 minutes, taking 16 minutes, but it's still OK. But your build times are, they are consistently increasing. The more tests you have, of course, the longer it runs. And at some point, yeah, the build times are so long that you cannot run them on every pull request. Nobody wants to wait 40 minutes for a pull request to be merged, at least not me. So how can we mitigate this problem? So yeah, let's analyze our test. Yeah, happy path tests are more relevant. Why? Because they affect 90 to 100% of the users, right? So we want to get fast feedback. It means we don't want to merge anything if any of the happy path test cases is something is failing. We want them to run frequently. And on the other hand, we have the unhappy path test cases in which, yeah, honestly, they affect to 5 to 20% of the users, yeah? And it's not so important to get fast feedback. So yeah, we can run them, of course, but not so frequently. So actually, if we only run the happy path test cases, we'll see that we are running many less tests, probably. So the build times will also decrease considerably. Usually, you have more test cases, in my experience, for unhappy path test cases as for happy path. So yeah, maybe you are thinking, yeah, OK, Sergio, but we've already written some tests for unhappy path cases. So, and honestly, I saw that there is value, so I don't want to let any single bug in. Yeah, so how can we decrease our build times, but also run the unhappy path test? So one approach you can take, especially if the full team is working on the same time zone, is to have some daily builds and some, not some, only 1 or 2 maybe, night builds. So the daily builds, the idea is that they run only the happy path test cases, and they run on every pull request, so nothing that is critical gets merged before we fix it. So that's the idea, and the night build then, on the other hand, will run only the happy path test case, once a day, 2. But the most important is that it's not during the working hours, so it's not blocking our development. Yeah, so these things can be merged because they are catching not so important bugs, and those bugs can be fixed tomorrow or after tomorrow, because they affect only 5 to 20% of the users. And they are visual bugs, probably, only that. So with an approach like this, we get fast development cycles. Yeah. Because the snapshot test will run much faster. So how do we implement this in code? Yeah, how does it look like? So for that, we're going to use something that I call like, filter parameterized test. So we come back to our parameterized test, to the array, and we see that they're happy and unhappy path test cases. So it's easy. Yeah, programmers are very good at copy pasting. So we copy paste things, and it's easy. On the left, we have the unhappy path, and on the right, the happy path. And now we just have to notify the test that it's a happy path or unhappy path test. How do we do that? With an annotation, yeah? You see, you can create it. An annotation like this, if you do it on your own, is 1 line of code, really. So if we want to run now only the, let's say, a happy path test cases, then we can do it from the command line with something like this by using the corresponding instrumentation runner argument, this annotation. And we can configure our CI to run this task only once a day. And then we can have another job in which we run the happy path test cases on the CI on every pull request. So let's recap how to do a snapshot testing effectively. So first of all, start small and simple. Yeah, try to test small pieces of UI instead of full screens whenever it's possible. It's not always possible. Second, aim to break the layout. So find bugs that even designers did not consider, because I can assure you that designers do not think of those things, not all of them. And the third one, group test by relevance, because it will give you some flexibility that can help decrease the build times. So thank you very much for your attention. This is some information about me. I'm writing some blogs about snapshot testing and testing in general because I really love it. You can find the code snippets in my GitHub. And yeah, you can follow me on Twitter and get notified about my blog posts or just about my life in general. So this is everything. Now is the time for questions if you have any. So thank you very much.